And we're back. YouTube doing me in. Microsoft doing me in. I'm done for. Alright. In this episode, we're getting VS Code. I'm going to probably delete. So go check your files up to this point. Or to this point. That's not right. Anyway. You need this, and this to at least get it to build. And then you need, if you're doing MS Build, you gotta have a VC project. So that's what we're doing back in VC. But we need this for cross-platform. This whole program is cross-platform. So, very handy program if we can get into it. So, made a shared object. Set up a reference to it in the static lib. In the console application, we're setting up the, you have to come in here, you add bin slash. Add this part. You can copy this and add this in a slash to here. You set up your language standards 20 and 17. Okay. Do the same thing with the static library. But in the console application, you need to go into the C++ section under General. Your inclusion is going to be your source inclusions. So we're going to go to, in our repos, we have Crossview. And then the source, the shared items project, this right here. We're going to dig that up. We're going to go into source. We're going to select that folder. That's going to be our include directory. Now in the linker, we're going to go back to General here, up in Configuration Properties. And we're going to grab that output directory, because that's where our static lib is outputting to. So we'll just grab that. Remember, we're in all configuration. If you messed up, hit cancel. Alright. So, we got that. In linker general, link additional library directories. Additional library directories. Go over here. Drop down, edit. Select a new line, search for it, drop it in, paste it in. No, actually don't do that. Sorry. Just click it and paste it right there. Then select off it. Make sure you hit OK. Okay. And that's where our lib is going to be. Because this one has the same, we set up this one with the same. Yes, we'll save that. We set the static library to the same output directory. So the lib will show up there. So that's where it's going to compile to. So let's go back into the properties of the console application. And we're going to go to, we got our lib directory. Now we go to input. We're going to go to this thing. We're going to hit edit on this one. We're going to add our library's name to this one. So it's example underscore static lib 1 like that. And then it's going to have a .lib. A static lib has a .lib when it makes it in VS Studio. So let's see here. So it's example underscore static lib with capital. It's all capitalized. 1.lib. Now, with that alone, excuse me. With that alone, we have successfully got our includes to not be read in all of our projects. Okay, now that does not mean it'll build, but drum roll, let's see if it'll build. Then we can talk about the code more. And I might take a quick break here because there's some wrestling about. But okay, so anyway, the utilities has our good old isConsole application function, which is supposed to be cross-platform. We can maybe even test that tonight. This framework actually does include Windows, which we see is working. That's good. So everything seems working for the most part. Now remember, we're rebuilding. There was no source. My whole hard drive's wiped out. Look. That's my wiped hard drive, so well, it's not wiped. We're hoping to recover the source in case we need it. In case there was something real good in it. But we're gonna straight up rewrite it because we have most of it already. And I did manage to upload Almond Core and save that source before any of this, but coroutine, thread pool, wait free queue was all rewritten, so we have to figure that mess out again. But it gave me those ones right away, and I have the input system back again now because I found that. And I generally explained and understood and watched my own videos to get back to this point. I've been working real hard. And I don't know how this is going to go, but we're going to get there. As long as this takes. Let me take a quick break. I'll be right back. Alright. We're back. We're back in our Independence stream. Independence from Visual Studio. Well, not really. You can't get away from it. No matter what you do as a C++ dev. Well, the thing is VS Code is cross-platform for the reason of Linux is good for servers, web servers especially, and want to see my glasses? Makes the lights look cool. makes me look cool. So, apologize for all the stream mess. It doesn't want to cooperate with anything I do, so. So let's get going. Let's beat it into submission. Now, where were we? We were still messing with the properties of this. I think we had everything we needed, though. We don't need a reference to... we already have included our own library, so we don't need a reference to Crossview in the console application. We already have that in the static lib. So we can just ignore the static lib from pretty much here on out. We're dealing with our source from the shared project and in the console application and other applications. I added a few projects while I was on break there. I got the Android. I've never seen the Android static library. These will change. Apparently I don't have the UWP stuff installed because it's all C#, I think, but you can actually include, well, I'm not sure if you include C++ directly in UWP or if it's in C++ or what the case is, but you can mix the two. There is a way. We're going to get there. We're going to get there. So, we've already come a long way. So, we're not going to talk about the coroutines just yet. Although I completely forget, I can't see the code with these on. So no more of those. I'll put those away. Those are my farmer's glasses. Pretty cool. Pretty cool farmer glasses. From the old. So, we've got the thread pool now. We've got the wait-free queue, which it uses. Oh man, we might have to... Okay, so, console application. Let's talk about it. Include Crossview. Structure, run it. Function, run it. Alman entry point. This is a namespace. This is the class name of the entry point. Now, just want to make that more visible. Alright, so then it has EP show, the entry point show, while true, pull events. Alright. So, Crossview calls entry point. Entry point a class in a header file that calls entry point cross-platform. It's in the element space because, like I said, layer build system. So class entry point, public, entry point, width, height, title, calls, entry point, cross-platform create. Then gets a unique pointer, a list of unique pointers, by the way, in a factory, to use the function within the cross-platform entry point. So, entry point entry point cross-platform. Memory. Entry point cross-platform. Virtual members. These are virtual destructor, default. Virtual, create entry point, show, and pull events. Static, unique pointer to its create. So only one is ever created. It is a singleton. However, in this case, it's normal to use a singleton. This is the modern singleton. This is fine. This is totally fine. We need a good anchor for, this is not a global singleton, you see. We need a good anchor for the entry point to stabilize everything else. Now, it works fine. So, here is entry point cross-platform, CPP. Now in Windows, we're going to have to do something about the PCH. But we're going to move to C++23 at some point also. Framework includes Windows within the shared project cross view. There's an include for entry point cross-platform, headless, utilities. Utilities just gives us that fancy function, is console application, rather than have macros and a configuration.h. We may still have that, but it won't contain the macros for the cross-platform. It'll all be handled internally. We're using memory again because it's using unique pointer again. There's another factory for entry point cross-platform. Well, this is actually the factory for the other class. For this static create factory, and it's here to create one of these. So it's a unique pointer inside a factory unique pointer. Okay, so it's like a double singleton, and sort of. Maybe technically, I don't know. But it's unique, it's not shared. So, creates headless entry point if we detect that this is a console application. We test to see if we have a console. If there is no console, at least on Windows this works. And I think I found a way in which I put it here. Oh, that may not be right at all. Uh-oh. Okay, that works. That works. Okay. So what it does basically is if there is a console, it uses headless and uses the console. So if you're building it in a console application, then there is a console because it's a console application. So go with the headless and just make an int main and get a console. If you build it with Windows desktop application, then first, not only would you have to delete some files, because you wouldn't need all this, but the way that it detects this is if there is no console, because there isn't. At least in Windows, like I said, it works. Then, if it's also Win32, then it'll choose the Windows desktop example. I've got to add something for UWP in there, but I can't even build UWP at the moment, so we'll have to see how that goes. Like this, we need this. Now, I actually don't know if this will build it. Let's find out. Now that we have it all set up, let's see here. We actually need to do this for all of them, because it'll spread files everywhere. Uh-oh. What's this? Thumb mode. Executes for thumb microarchitecture. This is applicable for ARM architecture. Okay. Client. Okay. Target name. Namespace. Okay. Yeah. Okay. What is going on here? Root namespace. Is this? Yeah, that's the one. It's just empty. Okay. Alright. It wants to play games. Okay. You know what? I won't even mess with it. Yeah. Sure, save it. Okay. I'm not going to mess with those either. I'm not going to mess with any of the others. Let's just clean it. And we won't even debug it. We'll just build it for now and see what happens. Four succeeded. Are we good or what? Come on. This is C++. That never happens first try. This is the first try. I saved it for you guys. Check it out. 4 of these built somehow. It's probably all, the ones that aren't mine, right? Okay, so let's go to bin. This is what we got. Nothing. We got nothing, guys. We got the Android lib. That's impressive. It doesn't do anything. It doesn't have a reference, but I could probably easily make a reference to the code and it would work. Let's see here. What else did we get? I don't know why anything's. Oh, we got the DLL. Oh, we got the see, like I said, none of the stuff that's mine. All right. Something's wrong here. This one's not going to the right place. Or something. Or it just didn't build. Let's find out what built. No target architecture. Uh-oh. On which one? On the DLL? The DLL needs the same thing that the lib needs. So therefore, we go and we put this info in. Link library dependencies. Oops, no, my bad. Additional library directories, but it's always above that. Okay, so let's put that in so the DLL can link. Wait. No. What am I doing? Actually, that's not a bad thing because DLLs can link against the static library. But I'll just take that out. That's fine. But the DLL, DLL needs a reference to the shared object. There we go. Let's clean it. 6 cleaned. Oops, I didn't mean to do that, but we know that didn't work. Okay, so it was all but mine. Fatal error on the static lib, and for no good reason, because it just fatally errored. It didn't even tell us anything. Let's see here. Okay, let us clean the solution. We're going to open the static lib so you can see it. We're going to build just the static lib. Oh, yes, yes. We're forgetting something very important. When you make the console application, you have to right-click on it, go to Build Dependencies, right-click on it, right here, and that's these project dependencies. Now, the project example complo, this depends on this or this, and they have to build, so only choose the ones you want. Now, the build order. So this is okay. It'll automatically choose the build order based on what you choose. So before we forget to do that again, example Windows project, build dependencies, project dependencies, static lib. Now we could try DLL with this one, but let's not. Now, because it takes more to do that. Now let's see what happens. Now that they have proper what? Well, we see that the lib didn't make it. 2 failed. Ooh, what is it doing? Is it still building? Oh, that. Alright, that's fine. we got this no target architecture. No target architecture. Let's see here. No target architecture. Oh yes, that is the that is this right here. Get there, target version. We can just add this to we'll just add this to framework. I think it has to be, it might need to be included first, so. Unexpected tokens, okay. If def defined. Oh, is this from? This is from this right here. No architecture. What do you mean no architecture? What do I do for a living? You're looking at it. Well, in case you're new around here, I have disabled children, so that's what I do. All right, so this might actually be caused by the extra entry points. What in the world? Okay, there it is. Framework. Okay. Okay. We'll just leave that open because I can see static web and then that doesn't confuse me. Okay. This is fine. So, what was the problem? Let's see here. Only 2 failed. That's strange. What? Why isn't it? No. 3 succeeded, 4 failed. see what we got.